Hello students, in this set of videos I'm going to discuss the solutions to the problem set question 2 where we're trying to write this series in sigma notation. So the first thing I see about this series is that if I factor out a 2, then I could rewrite this. Oops, let's go back to here. Okay, if I factor out a 2, then I could write this as 1 plus 1/3 plus 1/9 plus 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 1 over 243. All right, looking inside this, I see a geometric series with a first term of 1 and an r value of 1/3. So I know that my nth term is going to be given by 1 times 1/3 to the n minus 1 power. I also know that my nth term is 1 over 243, and I want to figure that out because I've got a fixed sum. I have a sum stopping point. So I'm going to say 1 over 243 equals 1 over 3 to the n minus 1, because of course 1 to the n minus 1 is just 1. So 3 to the n minus 1 equals 243. I can either solve that with logs, or I can solve it based on the fact that I know that 243 is 3 to the 5th. 1 over 3 to the n minus 1. This, of course, implies that n minus 1 is 5, so I have 6 terms of the sequence. So with my geometric series, I'm going to take the sum from k equals 1 to 6 of 2 times, now I've got my terms, and I'm adding up each term individually, so I'm going to use the formula for un. So I've got 1 times 1/3 to the n minus 1. Sorry, this parenthesis here should actually be on the outside because it's only the 1/3 that gets raised to the n minus 1 power. I could have also written this with the 2 in front and then done the sum from 1 to 6 of 1 times, of course that 1 can just go away, 1 over 3 to the n minus 1 power. So that's how I would do this first one. Now looking at this second one, the first thing I see is alternating positive negative signs. That says to me geometric series with an r value that's negative. But the whole thing isn't geometric because I'm not multiplying by a constant term. So up top in my fraction, what I see is an arithmetic series, and on the bottom what I see is geometric with the positive negative. So I'm going to look at this separately as 1 plus 3 plus 5 plus 7 plus 9. Of course, that's not what I'm doing. To add them up, I would actually have to add, I would have to have a common denominator. But I'm looking at the top separate from the bottom. So the numerator is arithmetic. Looking only at the denominator, I see 2 minus 10 plus 50 minus 250. So my bottom is geometric. So instead of saying denominator, I'm going to say geometric. And the lovely thing about sigma notation is it doesn't care that we make a common denominator. So I can do my sigma notation with my arithmetic series. So my arithmetic series is going to be u1 plus n minus 1 times d. My geometric series is going to be u1 times r to the n minus 1 power. Notice that this is where my negative comes in. We always have positive negative for geometric. Arithmetic is only going to be positive, getting smaller and smaller, turning negative, or always positive or always negative. It doesn't alternate the way a geometric can. So when I do my sigma notation, I can say sigma from k equals 1. We don't know where we're going to, so we could either say infinity or to n, the nth term. And then I'm going to put my arithmetic series on top. So I'm going to expand and simplify. 2 times n is 2n. 1 plus negative 2 is negative 1 over 2 times negative 5 to the n minus 1. If I'm actually adding, I can't add these up this way. It doesn't work that way. We know that we need a common denominator. But with my arithmetic series, I can test that this is going to work for me. So the way that I can do that, let me move this down here. So I can start plugging in my values. When k equals 1, I'm going to have 2 times 1 minus 1 over 2 to the negative 5 to the 1 minus 1 power. Plus, now I'm going to plug in k equals 2. 2 times 2 minus 1 over 2 times negative 5 to the 2 minus 1. And then I can plug in 3. 2 times negative 5 to the 3 minus 1, just to make sure that I'm on the right track. Plus dot, dot, dot. So let's test it. 2 times 1, 2, minus 1 is 1. 1 minus 1 is 0. Negative 5 to the 0 is 1, so we get 1/2. 2 squared is 4, minus 1 is 3, over 2 minus 1 is 1, so excuse me, negative 5 to the first power is negative 5 times 2 is negative 10. So I'm going to put my minus sign here. 6 minus 1 is 5 over 3 minus 1 is 2. Negative 5 squared is 25 times 2 is 50. And that's positive. So let's see if we match. And we are definitely matching our terms. So my arithmetic series on top, my geometric in the denominator, and because I'm using sigma notation, I can put those two things together. I can then evaluate it with my calculator if I know what n is. I have no other way to evaluate this though. I can't use my summation formula for arithmetic and geometric because to actually add these by hand, I would have to use the common denominator. All right. I hope that makes sense, and if not, please ask me about it in class.